Assemble the gel casting tray and comb. If required, seal the ends of the gel tray securely to form a tight seal. The volume of the gel to be prepared depends on the dimensions of the gel tray. Position the comb over the gel tray, ensuring that it does not touch the bottom of the tray. Prepare the gel on the basis of the percentage agarose required for the protocol. The agarose gel concentration percentage determines the range of separation of DNA fragments. For example, low percentage agarose gels are best for the separation of large DNA fragments, while higher percentage gels are best for smaller DNA fragments. Weigh the correct amount of agarose powder to obtain the expected percentage. Add the proper volume of electrophoretic buffer and carefully bring the solution to boil, preferably in a microwave oven, until the agarose is completely dissolved. Cool the solution in order to avoid the release of vapors when adding the intercalating dye to the gel solution. The most common intercalating ultraviolet fluorescent dye used to make DNA bands visible for agarose gels is ethidium bromide, in the proportion of 0.5 micrograms of ethidium bromide for each ml of agarose gel. The addition of ethidium bromide should be done under a chemical hood using nitrile rubber gloves or a double pair of latex gloves, since this reagent is carcinogenic by inhalation and in contact with the skin. Safer alternatives such as Cyber Green 1, Cyber Safe and Gel Red are less toxic for the operator and less dangerous for the environment, but are significantly more expensive. Now fill the gel tray with the agarose gel, avoiding the formation of air bubbles, and allow the gel to polymerize at room temperature for about 20 minutes. When finished, dispose any tips or gloves that have been possibly contaminated with ethidium bromide correctly. To run the electrophoresis, a support for sample preparation such as a 96-well microtiter plate, sample loading buffer and an appropriate molecular weight ladder are required, as well as the DNA samples. Aliquot the samples into the microtiter plate. Fill in the working sheet and identify each well on the microtiter plate with the corresponding sample identification number. Prepare the samples for the electrophoresis run by mixing 5 microliters of sample with loading buffer. The loading buffer allows for the tracking of the sample through the gel. It contains dyes such as xylene, cyanonol and bromophenol blue and glycerol, which renders the samples denser than the running buffer, so they sink to the bottom of the wells of the gel. Note that due to the millions of copies of DNA produced by PCR, this procedure is at high risk of contamination, and it is strongly recommended to open one PCR tube at a time and to use separate tips. Now that the gel has solidified and the samples have been prepared, carefully remove the gel comb from the solidified gel and the tape from the edges of the gel tray. Note that the holes left by the comb are the wells for the sample loading. Place the gel in its tray in the electrophoresis chamber and fill it with enough electrophoresis buffer to cover the gel completely. Load the samples following the scheme reported on the working data sheet. Now load the molecular weight marker, chosen on the basis of the expected molecular weight of the amplicon. Close the gel chamber and connect it to the power supply, setting up the electrophoresis conditions according to the length of the target fragment and the concentration of the gel. When the current is applied, the negatively charged DNA migrates towards the positive electrode. The matrix of the agarose gel acts as a sieve, allowing the smaller sized fragments to migrate faster than the larger ones, therefore separating fragments by size. Since the DNA is not visible during this process, the loading buffer helps the operator to control the run in order to avoid the DNA running entirely off the gel. When the run is finished, turn off the power supply and disassemble the gel chamber. Place the gel on an ultraviolet transilluminator or a UV light box to visualize the DNA bands. Note that using a protective visor